Hey everybody, welcome back to Mr. French Does Desmos. This is episode 4. We're going to be talking about how to get correctness streaks. I learned how to do this by looking at code, and it took me a long time to figure out, but I feel like I have a pretty good understanding of it now. So we're going to go ahead and start it up here. Let's go for it. Let's get, I think we need 4 components. We'll need a note component. We're also going to get a graph component. I want to put a button in here too. And then a place where they're going to enter in their math response. I'm going to try to zoom out. There we go. We'll zoom out just a touch there. Cool. I'm going to name these now. So we'll name this graph. We'll name this, I'll say prompt. We'll name this new problem. So as they click this button, they're going to get a new problem. And then we'll call this one input. There we go. So if I preview it now, so we have the 4 components. There's the graph. The node is empty right now. And then we're going to add some stuff to it. Then the new problem button and the input. So what I'm going to do first is show how we can get a random, really the goal for this video is to show how you can build answer streaks. I'm going to make a random generator. I'll say r equals random generator. And it's the seed for random generator is going to be that button that I named new problem and its press count. So I'll make my numbers here. I guess I'll say n1 for number 1 is going to be equal to the numeric value of, let's see, I'm going to get a number here. And we'll say the random generator, it'll be a random integer from, let's say, 1 to 5. So what this is going to do is it's going to generate random numbers from 1 to 5. It'll take that number. And I also don't want 0. So this was a trick I learned a while back, -1. So it's going to be a random number from 1 to 5 times -1 to the power of another random number. And that's going to be a random integer between 0 and 1. So it's just going to be 0 or 1. So this is a random number generator for the first number. I'm going to copy and paste this. And now we're just going to call that n2. So there we go. So let me just show you what that's going to do now. So if I go here and I do that same $ thing, and it can extract those values. So I'll call this n1, and then we'll say, we'll just to make sure that it's showing, we'll call this n2, right? So I'll say first number equals, and I'm going to adjust this. I'm just going to kind of show second number equals n2. So just to show it, if I keep clicking this like crazy, it's just randomly generating those numbers. I'm going to relabel this as try another. Okay. Cool. So we haven't even gotten to the correctness check yet, but I'm going to do that for a few other values here. The problem needs to show, so maybe I'll say I'll call something the example, and that's going to be like the actual add these numbers together. That's the piece that I'm going to just kind of build today. So the example is going to be the format of a LaTeX. I think it's LaTeX. It'll be n1 plus, remember the $ are extracting the values. So now if I show what the example is, go here, and if I just do the $, it now has that example. Let's see, yeah, now it's formatted to hey, do this, right? I need to make sure I code the solution. So solution is equal to, really it's equal to this, but it's not the format LaTeX. It is the numeric value. So I'm going to copy this, go here, paste it up. So solution is the numeric value of the example. So if I kind of show now the solution, so we're kind of slow. I like to do this as I'm building it. because then I can just delete these pieces or not show them even though they're still running. So 4 minus 4 is 0, 2 minus 2 is 0, negative 4 minus 2 is 6. You might notice that this isn't formatted in the same way that this is. Like this is the LaTeX version, this is just a number, and that's okay. I'm going to be fine with that. Cool, so then we have the solution. Now we're going to add in, let's see, correct or not. So correct. So correct is going to be equal to, so when solution, right, because we defined it as like the addition, when solution equals the input, remember input was what we defined as what the students say, okay? So when it equals that, let's see, then be 1. Otherwise, 0. So, ooh, what's happening? Objects of different types are never equal. Oh, okay. So this is a component name. This is like a value. So what I really meant to say here was go to input and get the numeric value of what they said. Now it's good to go. So if I show now, I'm going to bring up that correct thing that I defined. It should just be 1s and 0s. I wonder why it says wrong. Well, because it's not submitted yet. So the answer for this is 1. Let's just see what happens. I'll put 1 in. This correct thing is now 1. I'll put 14 in. It's now 0. Awesome. So now we have a way to like kind of correct, like get the correctness check. Let's see here. I'm kind of curious when the solution equals the input value and input is submitted, B1. I'm going to copy this. I guess, yeah, otherwise 0. So now it actually has to be submitted in order to be marked as correct. So let's just check that. So if I do it now, if I say 3, it doesn't count it, and then I submit, and it counts. There we go. Try another. It's 9, and it counts it. Boom. Try another, and resets. Awesome. So I'm going to pause for a second. Now we're going to go into the component of the graph. We'll go to the graph component. I'm going to make a list. Looks like this. We'll say it's 1, 2, 3, 4, 5, blah, blah, blah. We'll just do that for now. Actually, no, let's talk about how this is going to build. So what's going to happen is this list is going to be compiled from that correct bit. So the way that this list is going to work is if the numbers, like if the student's solution is correct and they submit, a 1 is going to go in here if it's correct. So this is what the list would look like if the student got 4 correct. And this was what was super exciting when I figured this out, or no, I understood the code. So the numbers being set in here are actually not going to be 1 and 0. If it's correct, it'll be a 1. If it's incorrect, I'm going to do this. I'm going to add in the next element. If this was wrong, the next element will be -4. And here's why. I'm going to make a text that says, we'll make a, yeah, we're going to say, we're going to build a number that's the current. And that number is simply just going to be the total of L. So the current streak right now is 0. Previously, the current streak was 4, right? And that should make sense. But the way we're going to code it is if it's wrong, the next number that goes in is -4. So this number goes down to 0. And then as we get ones coming in, now the total is back to 3, right? Because this -4 canceled these out. And so I need to go back actually in here, I believe. Oh, well, let's add in a few things. So, okay, that's one. I'm now also going to put in a longest streak, and that is going to be, well, we'll get to the longest streak in a second. I need to create that like opposite number. So I'm going to call that the delete number. Delete. And really, delete is going to be the opposite of the current. Right? So this is the delete number. It's going to be the opposite of the total. And so that's the number that's going to get sent in if it's wrong. Okay? So let's just see how this is working. I'm going to get a little visual here for the list. So I'm going to make a series of points just for fun, just to see if it's working or not, like that list is being created. So I'm going to call this, it'll be a list from 1, comma, dot, 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 to the length of L. Okay, so the length of L is now, it looks like it's 8 elements. And then we'll say comma 2. So just as we're checking to see. And then the label here is going to be a little bit different. The label is going to be the values of L. And I'll get rid of this. This is just to make sure that we can see that it's working. So if I preview it now, obviously it's there because those numbers are there because I've defined L. But I don't want L to be that. I want L to be that list of like the ones and zeros from the students. So what I'm going to do is I'm going to tell the component here that I'm going to tell the graph that the number list L needs to it'll be input. No, it'll be prompt. Script. I can't do history. Ooh, let's pause for a second. Figured it out. So I need to extract a value. I can't extract a value. So what this is doing is it's going to try to go to prompt to get a number, but we want to get the student number. So what I'm going to do is in here, I'm going to tell some of these numbers to go somewhere else. So like this correct thing, I'm going to send it in here. So I'm going to say, I'm going to define a new variable, but it's going to go to the input script, and it's going to be, oh, sorry, not input. Oh my gosh, input is this. It'll go to the prompt script, and it will be the number correct. So now I can just do a few things in here. So now I can tell this number list to go to input history, and we'll say correct. So it's going to take the history of that number in the input. So it should be good to go. Let's see if this works. Okay, so the answer is -3. -3, submit. It's not working. Let's figure this out. I'm going to try something else. So I'm going to go in here and get rid of this correct bit. I think what's important for this input is creating something slightly different. So I'm going to get this, I get confused because we have correct and solution. So I'm going to take the solution bit from this. So I'm going to go in here, I'm going to call something solution, go to the prompt, script, and go to solution. Okay. So now I can say capture correct. So this correct here is coming from this. So if I labeled this correct, I want to make sure that that's consistent. So the correct that I'm capturing is coming from this component. And we're going to capture correct. So this is what's going to happen when this numeric value is equal to solution. So when this numeric value is equal to the solution up here, then you're going to be the number 1. Okay. Otherwise, you're going to go to the graph. You're going to get the number, and you're going to get that delete number. Boom. So it's either going to be 1 or the delete number. Remember, the delete number is the opposite of the current total. So let's see if this works. Okay. So it's -3, -3, enter. Boom. So that's correct, right? We'll try another. The answer is -9. Oops, that's positive. So it's 2 1s in a row. Now, we'll try another. The answer is 6. I'll put 3. Oh, whoops. I didn't submit it because it needs to be 3. So the answer is 1. I'll put 3. Submit. Boom. So now the current streak is going to be 0 if we add it up. So let's say I'm going to put another point here. So I'll just put the point, I don't know, 2, 4. Okay. And the label will say current equals, and I'm going to zoom in just a touch here. We'll put the LaTeX of current. So now the label should be current. I spelled that right? Yeah. Why are you saying I didn't spell it right? Get out of here. Huh? Why is that not working? Why is that not working? Ooh, I know why, because I didn't put the $sign around it. Oopsies. There we go. So now the current is 3. Perfect. And this is going to be kind of clunky for now, but we have a current streak of 3, and the longest streak we haven't coded yet. So the longest streak, it's actually not too bad. The longest, surprisingly, is not too bad. So what you do is you take the maximum of the opposite of L. So L is this, so you take the longest of the maximum of the opposite. So since the delete button is also kind of like the positive version of this delete number is also the longest it's been so far, or I guess it's a streak. So what this is going to do is it's going to have a bunch of -1s and some numbers that aren't -1. And so this would turn out to be +4 in this one. So the maximum of that list is going to be all of the positive versions of the streaks. So it'll always give you the largest streak. So now you can kind of do the same thing here. We'll do 3 and call this the longest. We'd have to adjust this. We've got to be careful. It's got to stay in that $sign. Awesome. Cool. So now we can just check it. It's undefined. There's ways to fix that. I'm not going to get into that right now. But just to see, we do now have, whoa, the longest is -1. What? Okay, I figured it out. So not in the CL, in this graph here, okay, I thought it was easier, but it's not. Previously, it was just the maximum of the opposite of L. But like if there was only one number in, then -1 is the highest. What this is going to do is it's going to take the maximum of 2 options. So it's either going to be the maximum of -L, which once again, that's going to produce like the maximum streaks. So for example, like right here, let's show what -L is. I kind of want to show that too. I'm going to copy this for a second. Let's have this be -L. No, I can't do it. I'd have to define that. Ugh, gross. So -L is a list. Can I draw with this stuff? So this -L would be like -1, -1, -1, -1, and then a +4. So the max of this is now 4. But before we had like these numbers here, the max of the first 2 was -1. That's why that -1 was showing up. So now I'm going to put this. I'm going to say, well, take the maximum of this list, and also the current total. So it's going to like move as it goes. So let me show you how that's going to work here. So let's say it looks like the current total right now is 3. So if we show that, perfect. So this is the negative L bit, right? And then the current total is 3. So it's going to take the maximum of these two sets, these two options, and 4 beats it, right? Oh, weird. So 4 beats it. So now if we check it, we can go into the preview, and the answer is -1. So we'll say -1. Boom. Do a few more. Say 8. Cool. So, and then let's do a few more here. 8, got it. It's the same problem. 6, got it. Now if this works, I'll put in that. Boom. So now the longest streak is 4. Took the opposite of that. There it is. And now it's not having those negative ones there. So then we can do it again. It's 1. So our current is now 1, and the 4 stays there. So we can kind of gussy this up a little bit better. We can kind of get rid. We want the example to be there. I don't need that because it's still like in the computation layer. Like it's still in here. We don't need to see the solution right now or the correct bit. We could say, simplify the expression. I'm a big fan of doing this. Cool. Right. And we can make this look a lot better too. We don't need to see that list right there. And there's different ways. I think in the next video, what I'm going to show you is kind of how I approach it. But now you have a way to keep track of the current streak and the longest streak. And there's different ways to make different types of problems too. It kind of just depends on how you identify how it's correct or incorrect. And you can copy and paste all this information. Like I've done this with solving equations. I've done this with identifying 0, 1, and infinite solutions for equations. There's a lot of different ways that you can adjust. It kind of just depends on how do you check and answer. So essentially, the next video I'm thinking is going to be showing it like how I've kind of modified this graph to make it look a lot sharper and nicer. And then so usually what I have is like little bars on the side that show, there's like a little bar here, and there's like a little bar here, and it's like all blank, but it kind of has like your current streak eventually show up here, and then your longest streak, and you can code that to different values. For this one, maybe I'd want their longest streak to be, get 5 correct in a row. That's like a warm-up. Another thing I don't like here is that students could just like try another one whenever they want to. It's like, oh, yep, got that 7. Boom, good to go. I'm going to do another until it shows me 2 positives added together, right? So as a student, nope, another 7. Boom. Got it. So there's a way to get around this that I'd like to show. So in the next video, I'm going to show you how to make those bars, and then also how to make it so students don't just get to like click until they find one that they want. Awesome. Thanks for joining. This has been Mr. French Does Desmos on how to find the current and longest streak. Thanks.
Bye.